Let's turn though to a fascinating story because scientists have discovered a gigantic ring-shaped structure in space which is so big it challenges our understanding of the universe.
NASA has just revealed the hidden mysteries of the Kyper Belt. The Kyper Belt is a distant region beyond Neptune and is home to mysteries yet to be fully understood. But what secrets are locked in its icy objects and dwarf planets? And how will its exploration redefine our future in space? Join us as we explore the Kyper Belt's objects and NASA missions that led us to them. Number 1. The Kyper Belt explained. The Kyper Belt, a vast donut-shaped region beyond the orbit of Neptune, is an integral part of our solar system. It begins at about 30 astronomical units from the Sun, extending outwards to roughly 50 astronomical units. In comparison to the well-known asteroid belt, the Kyper Belt is significantly larger and more distant, making it a distinct feature of our solar system. This region is primarily composed of small, icy bodies that are remnants of the solar system's formation about 4.6 billion years ago. And now, NASA has revealed what has been hiding in this belt. The objects inside the Kyper Belt are diverse, including a mixture of ice, rocks, comets, and dwarf planets. These elements are often referred to as Kyper Belt objects or trans-Neptunian objects. The icy composition of these bodies is due to their far distance from the Sun, which ensures that temperatures remain low enough to keep volatiles like water, methane, and ammonia in a frozen state. The formation of the Kyper Belt is closely linked to the early stages of the solar system. During its formation, the protoplanetary disk surrounding the young Sun was filled with gas and dust. The inner regions of this disk merged to form the planets we know today. In the outer regions, where the Kyper Belt lies, materials grouped more slowly. Due to the lower density of matter and the influence of Neptune's gravity, these objects could not merge into a larger planet. This led to the creation of the Kyper Belt as we know it. The existence of the Kyper Belt was hypothesized long before any direct observations were made. In 1943, Irish astronomer Kenneth Edgeworth suggested the presence of a region beyond Neptune, filled with small celestial bodies. Later in 1951, Dutch-American astronomer Gerard Kuiper theorized a similar disc-shaped region, adding credence to the idea. However, it was not until the 1990s that the first concrete evidence of the Kyper Belt came to light. Number 2. Notable objects and features in the Kyper Belt. The Kyper Belt is home to a number of dwarf planets, the most famous of which is Pluto. Discovered in 1930 by Clyde Tombaugh, Pluto was originally classified as the 9th planet in our solar system. However, following the discovery of similar-sized objects in the Kyper Belt, there was the adoption of a new classification system. In 2006, Pluto was reclassified as a dwarf planet by the International Astronomical Union. Beyond Pluto, other significant dwarf planets in the Kyper Belt include Eris, Makemake, and Haumea. Eris, discovered in 2005, is slightly larger than Pluto and has one known moon called Dysnomia. Makemake, discovered in 2005 as well, is known for its bright surface, likely due to a layer of methane ice. Haumea was discovered in 2004 and has 2 moons. It is recognized for its elongated shape due to its rapid rotation. These dwarf planets are crucial for understanding the diversity of bodies in the Kyper Belt and studying the outer solar system's evolutionary history. Their varied compositions, sizes, and orbital characteristics offer invaluable insights into the processes that shaped the early solar system. Kyper Belt. Objects and trans-Neptunian objects are terms used interchangeably to describe the variety of other objects found in the Kyper Belt. These include a huge collection of icy bodies, ranging from small rock-sized particles to larger objects with diameters over 100 kilometers. One of the landmark discoveries in the Kyper Belt was the object known as 1992 QB1, found in 1992. This object was the first confirmed Kyper Belt object, opening the door to the discovery of thousands more. These discoveries have provided astronomers with a better understanding of the Kyper Belt's size, structure, and composition. The size and distance of Kyper Belt objects make them difficult to study, but advances in telescope technology have allowed astronomers to gather more information about these distant objects. For example, the Hubble Space Telescope has played a crucial role in identifying and studying Kuiper Belt objects, contributing significantly to our knowledge of the outer solar system. A notable feature within the Kuiper Belt is the prevalence of binary systems, which are pairs of objects that orbit around a shared center of mass. These systems are intriguing because they are often composed of two objects similar in size, making it difficult to distinguish a primary body from its companion. One of the most famous examples of a binary system in the Kuiper Belt is the pair of Pluto and Charon. Charon is nearly half the size of Pluto, and their mutual gravitational pull causes both to orbit around a point in space between them, rather than one orbiting the other. This characteristic makes the Pluto-Charon system a fascinating subject for astronomers. The existence of binary systems in the Kuiper Belt provides crucial information about the formation and evolution of objects in the outer solar system. Studying these systems helps scientists understand the processes involved in their formation, such as the collision and subsequent gravitational capture of objects. Number 3. The mysterious Aron in the Kuiper Belt. Many mysteries still remain inside the belt. In April 2016, NASA's New Horizons probe, while traveling across the distant Kyper Belt, detected an intriguing object named Aron. The object is named after the Celtic god of death, war, terror, and revenge. Aron presented a set of peculiar characteristics that caught the interest of scientists. The object exhibited an unusual luminosity pattern, alternating between illuminated and dark states in a precise rhythm. This behavior suggested that Aron was rotating, completing a full spin approximately every 5.5 hours. Typically, objects in the Kuiper Belt are composed of rock and ice. However, Aron's swift spin suggested a composition of material stronger than the usual rock and ice mixture found in this region. The centrifugal force generated by its rapid rotation could potentially tear apart a body made of conventional Kyper Belt materials. This led scientists to speculate about the presence of more powerful materials in its structure. As New Horizons approached Aron for a closer examination, an unexpected and unexplained event occurred. The probe's transmission was suddenly and inexplicably cut off, leading to speculations about potential interference. This interruption in communication raised questions about whether external forces were at play, potentially obstructing the probe's ability to transmit data. Before the loss of contact, scientists observed that Aron's rotation was consistent with the behavior of a large spacecraft. The spin speed suggested the creation of artificial gravity, a concept familiar to NASA and space engineers who have long considered the use of rotation to generate gravity in space. These unique characteristics of Aron opened the door to various theories and hypotheses, including the possibility of it being an alien spacecraft. The concept of a spinning structure creating artificial gravity has been a subject of NASA research for decades, with experiments conducted to understand its effects on human physiology. However, the rotation speed of Aron, while sufficient to generate gravity, was not favorable for human habitation. This suggests that if Aron were a spacecraft, its inhabitants might be non-human. Speculations extended to the potential nature of beings capable of living in such an environment. Theoretical models suggested that life forms adapted to low-gravity environments might have significantly different physical structures compared to humans, possibly resembling more amorphous or tentacle-like forms. The Kuiper Belt's distant and dark nature makes it an ideal location for an observation post, away from the immediate vicinity of the planets. If Aron were an alien spacecraft, its location in the Kuiper Belt would provide a strategic advantage for observing Earth and other planets without immediate detection. This theory aligns with the idea of the Kuiper Belt being a potential hotspot for extraterrestrial observation due to its remote position and the abundance of objects providing cover. The New Horizons probe's encounter with Aron and the subsequent loss of communication left many questions unanswered. The true nature of Aron remains a mystery, supported by the lack of immediate plans for new missions to the Kuiper Belt. This continues to fuel speculation and debate within the scientific community, also making it a subject of interest for future exploration and study in the quest to understand the mysteries of the Kuiper Belt. Number 4. NASA's role in exploration of the Kuiper Belt. NASA's exploration of the Kyper Belt marks a significant chapter in space exploration, particularly through missions like Pioneer 10 and New Horizons. Pioneer 10, launched in 1972, was the first spacecraft to travel through the asteroid belt and make direct observations of Jupiter. Although it did not specifically target Kyper Belt objects, its journey into deep space laid the groundwork for future explorations into the outer solar system. The New Horizons mission, however, has been central to our understanding of the Kyper Belt. Launched in January 2006, New Horizons had a primary mission to perform a flyby study of Pluto and its moons. After a journey of over 9 years, the spacecraft provided the first close-up images of Pluto in July 2015. These images revealed a diverse landscape of mountains, glaciers, and plains, transforming our understanding of the dwarf planet. Following its successful encounter with Pluto, New Horizons investigated further into the Kyper Belt. On January 1, 2019, it flew past Arakoth, previously known as Ultima Thule, an ancient Kyper Belt object. This flyby made Arakoth the most distant object ever visited by a spacecraft. The data collected offered invaluable insights into the conditions and processes in the early solar system. The New Horizons mission has yielded groundbreaking discoveries. The detailed images and data from Pluto revealed a complex and active world. Pluto's surface features include nitrogen ice glaciers, rugged mountains made of water ice, and a variety of surface colors, suggesting a complex geological history. The exploration of Arakoth provided crucial information about the formation of planetesimals, the building blocks of planets. Arakoth's bi-lobed shape suggests it formed from the slow formation of 2 separate bodies in the early solar system. This observation supports theories that the early solar system's planetesimals formed through the gradual accumulation of smaller objects, rather than through violent collisions. NASA continues to plan for future missions to study the Kyper Belt in more detail. The success of New Horizons has paved the way for further exploration missions. Potential future missions may include detailed studies of other Kyper Belt objects. It may also include further analysis of the dynamics of the Kyper Belt and the investigation of the outer edges of the solar system. One proposed mission is the Interstellar Probe, which would travel further into the outer solar system and potentially beyond, exploring the interstellar medium. While still in the conceptual phase, such a mission could provide unprecedented data about the solar system's outer boundary and the transition to interstellar space. NASA's exploration of the Kyper Belt, particularly through the New Horizons mission, has greatly enhanced our knowledge of this remote region. The ongoing exploration with future missions in planning continues to be an exciting area of research and new discoveries. Number 5. Scientific significance of the Kyper Belt. One of the most significant insights gained from studying the Kyper Belt is the evidence of Neptune's outward migration. As Neptune moved from its original position closer to the Sun to its current location, it is believed to have interacted gravitationally with the Kyper Belt, reshaping the orbits of many of its objects. This interaction supports the theory of planetary migration and has implications for understanding the dynamic history of the solar system. The Kyper Belt is also crucial for understanding comets, specifically the short-period comets that originate from this region. These comets are believed to be Kyper Belt objects that were knocked out of their original orbits and sent into the inner solar system. Studying these comets provides valuable information about the composition of the early solar system, as they carry volatile materials from the outer regions closer to Earth. By analyzing the composition of these ices and their interaction with solar radiation, researchers can infer the chemical processes occurring in the early solar system. Despite the significant advances in our understanding of the Kyper Belt, many questions remain unanswered. The vastness and remoteness of the region pose considerable challenges for exploration and study. The size and faintness of Kyper Belt objects make them difficult to observe, even with the most powerful telescopes. One of the major unanswered questions is the precise number and size distribution of objects in the Kyper Belt. Determining the exact population and size distribution of these objects is crucial for understanding the mass and dynamics of the Kyper Belt. Another area of interest is the potential existence of an undiscovered large planet, often referred to as Planet 9, in the outer reaches of the solar system. Some scientists hypothesize that the unusual orbits of certain distant objects could be influenced by the gravitational pull of a yet undiscovered massive planet far beyond the Kyper Belt. The continued study of this region promises to unravel more of the solar system's secrets. Number 6. The mysteries and unknowns of the Kyper Belt. The Kyper Belt may also contain clues about the interaction between our solar system and the interstellar medium. The outer edges of the Kyper Belt are a frontier, marking the boundary where the sun's influence wanes and the interstellar space begins. Exploring this boundary could reveal information about the solar system's protective bubble, known as the heliosphere, and how it interacts with the galaxy at large. Exploring the Kyper Belt presents a unique set of challenges. The primary obstacle is the vast distance from Earth. This distance makes travel to the Kyper Belt time-consuming and limits the amount of data that can be transmitted back to Earth. Spacecraft like New Horizons, which visited Pluto and Arrokoth, have provided valuable data, but these missions are complex, expensive, and few in number. Another challenge is the size and faintness of Kyper Belt objects. Most Kyper Belt objects are relatively small and dark, making them difficult to detect and study from Earth. Even with advanced telescopes, many Kyper Belt objects appear as mere points of light, offering limited information about their physical characteristics. Additionally, the huge area of the Kyper Belt means that it cannot be studied in its entirety. Rather, scientists must select specific targets for observation and exploration. This selection process requires predictive modeling and extensive research to ensure that missions are directed toward objects that will yield the most scientific value. Another area of theoretical interest is the study of the Kyper Belt's formation and its initial mass distribution. Scientists use computer simulations to understand how the Kyper Belt might have evolved over billions of years. These simulations help explain the current distribution and dynamics of Kyper Belt objects, as well as the history of interactions between these objects and the giant planets. Another area of interest is one right next to the Kyper Belt, a distant and mysterious region known as the Oort cloud. The Oort cloud, named after Dutch astronomer Jan Oort, who theorized its existence, is a vast and distant spherical shell surrounding the outermost edges of our solar system. It is believed to extend from about 2,000 astronomical units from the Sun to as far as 100,000 astronomical units. This makes it the most remote region of our solar system. This immense distance means it's almost a quarter of the way to the nearest star, Proxima Centauri. Unlike the relatively flat plane of the Kyper Belt, the Oort cloud is thought to be a thick spherical shell, almost like a bubble encompassing the solar system. It is hypothesized to contain billions, possibly trillions of icy objects, primarily composed of water ice, ammonia, and methane. These objects are remnants of the early solar system, left over from the formation of the Sun and planets. The Oort cloud is significant as the believed source of long-period comets, those with orbital periods longer than 200 years. These comets are occasionally pushed by gravitational interactions, possibly with passing stars or molecular clouds. This push puts them on trajectories that bring them into the inner solar system, visible from Earth. Due to its extreme distance and the small size of its objects, the Oort cloud remains largely theoretical. Direct observation of objects within this region is beyond current technological capabilities. However, the study of long-period comets provides indirect evidence of its existence. Understanding the Oort cloud can offer crucial insights into the history and evolution of our solar system and the processes that shaped it billions of years ago. In addition to the Oort cloud, the concept of rogue planets represents a fascinating area of astronomical research. Rogue planets are celestial bodies that do not orbit a star and instead drift freely through the galaxy. Rogue planets are thought to be planetary mass objects that have been ejected from their original solar systems. This ejection could occur due to gravitational interactions with other planets or as a result of the death of their host star. Without a star to orbit, these planets drift independently through space. For example, objects like CFB-DSR 2149, 0403, and WISE 08550714 are potential rogue planets. CFBD SIR 2149, 0403 is a free-floating object identified in interstellar space and a young planet ejected from its system. WISE 0855-0714 is another candidate notable for being one of the coldest objects discovered outside our solar system. Its temperatures are similar to those of the icy moons of Jupiter and Saturn. The discovery of rogue planets challenges traditional understandings of planetary formation and solar system dynamics. These planets can vary greatly in size, composition, and temperature. Studying them can provide insights into the diversity of planetary bodies in the galaxy and the processes that lead to planetary ejection. Detecting rogue planets is exceptionally challenging due to their lack of a star to illuminate them. They are typically discovered through gravitational microlensing events, where a rogue planet's gravity bends the light of a distant star. Advanced telescopes and space observatories are crucial in identifying and studying these mysterious objects. This shows how much there is to explore in space and how many mysteries still lie ahead. Number 7. Colonizing the Kyper Belt. Challenges and opportunities. Envisioning human colonization of the Kyper Belt introduces a new and ambitious aspect of space exploration. Key to the interest in the Kyper Belt is its abundance in resources such as water ice, methane, and other volatiles. These materials are vital for sustaining human life and could be instrumental in supporting long-duration space missions. The potential for on-site resource utilization is a significant driver for considering colonization, as it could provide the raw materials necessary for life support and fuel. The primary challenge in colonizing the Kyper Belt is the sheer distance from Earth. This factor has its own set of requirements. The development of advanced propulsion systems and spacecraft capable of enduring long-term space journeys are needed. Innovations in spacecraft design are essential too. This includes the use of lightweight, durable materials and efficient propulsion methods like nuclear thermal or electric propulsion. Creating habitable environments in the extreme cold of the Kyper Belt is another significant challenge. Colonies would require advanced thermal insulation, heating systems, and sustainable power sources to withstand temperatures as low as -330 degrees Fahrenheit. Establishing reliable communication networks to overcome the vast distances involved is another crucial aspect. The development of advanced, long-range communication technologies would be necessary to maintain regular contact between the colonies and Earth. Additionally, colonizing the Kyper Belt raises important ethical questions, particularly concerning the potential environmental impact on planetary bodies. It is essential to develop responsible practices for resource extraction and to minimize interference with the natural state of Kyper Belt objects. International collaboration will be crucial in this endeavor, pooling resources, expertise, and technologies from across the globe. This cooperative approach can address the multiple challenges more effectively and ensure responsible expansion into the Kyper Belt. The prospect of colonizing the Kyper Belt represents a bold leap in humanity's spacefaring endeavors. It includes overcoming significant technological, environmental, and ethical challenges. However, there are many rewards to consider. In terms of resources, scientific discovery, and the expansion of human presence in space. They present a compelling case for future exploration and potential habitation of this distant region of our solar system. Thanks for exploring with us on Beyond Discovery. If you enjoyed these revelations, click now on the next video that pops up on your screen. It's unbelievable.